Hi. My name is Na Li, lead of on-device machine learning developer tools at Google. Today, my colleague Jason and I will provide a new update on VisualBlocks, a no-code ML prototyping tool that we launched last year. Let me give you a quick review of what we have introduced last year. Then I will pass to Jason to talk about the new excitement this year. We have created VisualBlocks, an editor to enable developers and decision makers to work together when using machine learning, focusing on the problem they're actually trying to solve, instead of being blocked by code complexity and technical barriers. All key features are neatly packaged in a node graph-style visual editor as shown. When you drag out from one of these nodes, they can suggest valid things they can be connected to automatically, allowing you to quickly produce an end-to-end prototype that you can share with your wider team, who can then try it on their own machine with custom data or input devices. Let's quickly walk through the key parts of the user interface of VisualBlocks that you can see. First, you can see the node library panel in the bottom left of the screen. Nodes are grouped by key themes, such as inputs, models, outputs, and more. This makes it easy to find what you need. You can also use the search box in this area if you prefer that. Second is the editor, to which you can drag nodes and then chain them together to make custom graph flows to perform any task as needed. Finally, along the top, you have the output window, also known as the runner, which shows the outputs of executing the graph you define in the editor below. You can also load and save projects using the import and export buttons on the top right. Now let's switch to a live demo. Okay, now we're in VisualBlocks. I'm going to use VisualBlock to build an AR sticker effects in just a few minutes. Let's start with the image input. Let's use this nice portrait. What I'm going to do is drag out an edge from this output. Then it will show a list of nodes that I can connect to. Nodes that are often connected together will appear on the top. Let me choose this body segmentation node. It will download the model to the device and run automatically. Let's see the results. What this model does is it removes the background, so we have a clean foreground to work with. Then I'm going to feed this foreground to a second model called face landmarks. Let's see the result. This model will identify a set of key points on human face. If you know where these key points are, you can attach AR stickers to it so that they can move with the key points. Let's make a cool effect with it. I'm going to connect this to an AR sticker. As you can see, it already automatically connects to the face landmarks and the original image. All I have to do is to provide a sticker image. And I'm going to upload one from the internet. Here I'm choosing a sunglass and making sure I select it. Now we have the sunglass with the portrait. I want to move to the right place. There's a few options we can change. I'm going to first move this to the center and make it larger. And now it's on my head top. I want to move it to overlay on the girl's eyes. And you see, here it is. And next step, I'm going to add a virtual background to make it more interesting. There's a node for it called Image Mixer. I need to give a background image. Let's choose the Safari one and making sure we use the right mixing mode, destination over. Then the foreground will be rendered on top of the background. And as a last step for the AR effect, let's make it real time. What I'm going to do is use a camera stream. And you see me from the camera stream. And I'm going to replace it. I'm going to replace the static image with this camera stream. Okay, let's check out the final results. Okay. Yeah, there I am in a virtual world standing in front of a Safari and wearing my virtual sunglasses, moving with my head. Okay, now let's switch back to the slides. All right, now that you have seen ViroBlocks in action, let's talk about how others at Google have been using it. ViroBlocks has been used internally to help researchers, designers, PMs, and engineers to find new AI-powered use cases. Let's see a few examples from the Duet AI team. First, I want to share an example where the team was able to import a Google slide deck into ViroBlocks and ask for feedback from Gemini, Google's multi-model large language model. Here you can see it in action. First, you enter the Google Docs slide URL that you want to analyze. After it's loaded, you can see a preview, and you can then ask Google Gemini to give suggestions on how to improve it. After a moment, it returns a response. And as you can see, it gives us a very detailed answers on what works and also what could be improved. Let's take a moment to read through it. I think the suggestions it has come up with are pretty good. It suggests that the title should be more specific, and maybe we could add a few more visual elements. Okay, so now let's take a moment to look at how this application actually works. We use 6 nodes to accomplish the task. The larger green node on the left takes a URL that reads the slide thumbnail and passes it to the yellow node on its right that converts it to an actual image. The larger red node further along is the Gemini node, which takes the image combined with a text prompt. In this case, the prompt I use is explain this slide in great detail and give me suggestions on how to improve it. Finally, at the end, we connect the output of the Gemini call to a Markdown viewer to render what comes back. Next is an example that allows you to create an assistant to summarize the latest local news automatically. In this example, it starts with a query to the Google Search API to get the latest news for a topic, say news for New York or California. And then we ask the model to provide a highlight summary of the latest news from the Google Search webpage. This time, we chose to use Google's PaLM model. So let's see it in action. Great, it works. Now this is something I would like to get every day. Next up, imagine you want to build a creative storybook experience, complete with imagery that represents it. Here we use Gemini to create a storybook. I have ViroBlocks on the left and the chat app on the right. In the chat window, I typed a cute Wesley wizard called Harry Woofer. And let's see ViroBlocks and Gemini working in action. We also use an image generation tool that can generate styled images based on the prompt. And we use a custom script node that uses HTML and JavaScript to render the text and the image as a whole as a storybook. We can further change the style to generate different images. I changed to photorealistic. Let's see it in action. Let's give it a few moments to generate the image. Here you go. You would need to experiment with prompts to see what gives your desired effect the best. Later, we can then import our creation for further edits and collaboration via Google Docs. I hope you like these demos. A lot of them are made with a new feature, ViroBlocks Custom Nodes. I will hand over to Jason to walk you through how to build your very own ViroBlocks Custom Nodes. Please welcome Jason.
Thanks, Star, for that great introduction. Hello, everyone. I'm Jason Mays, Web AI Lead here at Google. And as you've seen, visual blocks can be really powerful. But you might be wondering, how did the team make those useful nodes that you saw in action? Well, in this part of the talk, I'll show you how to create your very own custom nodes to do anything you want for your own custom company, logic, or whatever you need. Now, since launching Visual Blocks in 2023, I've spoken to many of you throughout the year, and time again, I saw requests for people wanting to run custom logical code. But on that note, you also wanted to be able to make nodes that could work with all our existing offerings, so you didn't have to start from a blank canvas, especially for common reusable things like accessing sensors like the webcam or common output visualizations. So on that note, hello custom nodes. Built-in nodes might not always be perfectly aligned with your unique requirements, but this is where custom nodes can shine. And even better, they're just regular JavaScript web components. So it's really easy to make these using your favorite framework or no framework at all, as web components are part of modern web browsers out of the box. Now, at this point, you might be wondering, what can a custom node do? Well, the short answer is, if you can write it in JavaScript, you can turn it into a custom node. So yes, pretty much anything. Maybe you've got some custom client-side logic you want to execute. That could work. Or maybe you wanted to call a new API from your cloud service. That can be turned into a custom node as well. And with that, the nodes you create can work with all our existing ones and even other people's creations, assuming the input and output types actually match, allowing you to innovate faster by reusing the work of others. OK, so let's walk through making our own custom node. To illustrate this, you'll be creating one that takes some input text, makes it uppercase, and outputs that transform text. Now, this is a very simple example, but it will teach you all the key parts of creation. And what are those? Well, there's 3 key elements. First, there's the node specification, or node spec for short. This is where you define the inputs, the outputs, and the various configurable properties you want your node to have. You've then got the web component implementation, which is where you'll write your custom logic. And then finally, you've got the registration, so you can tell VisualBlocks how to use it. So first up, the node specification. Simply put, this is just a JavaScript object that contains all the metadata about the node. You can see an example on the right what that looks like, but let's dive a bit deeper. Essentially, the node spec explains to VisualBlocks how to render the node and what inputs and outputs it can take or produce. So let's walk through the actual code to see this in action. Also, before we get started, any of you got laptops or want to follow along, you can grab a copy of all the code you're about to see today on the link shown. So feel free to take a photo or open up your laptops if you have them, and you can zoom in as I talk about things. I'll give you a few seconds to do that, and then I shall continue. I see some phones going up. Very good. Always good to see participants. Very nice, very nice. OK, and of course, this will be up later if you miss it, so don't worry about that. OK, so let's continue. So first of all, you're going to start by making a new file called makeuppercase.js, and you'll start by defining a constant, which will contain all the properties, inputs, and outputs for your node. And it's important to ensure that this constant name is unique, so prefix it with your node name, which should also be unique. In this example, you'll name it as node name, node spec. OK. Next step is to define an ID. This is the unique name for the custom element you'll create later on. This must also be unique, as all the nodes registered with VisualBlocks must have unique IDs as well. As such, it's recommended to prefix with your node's name or something unique to you, like your brand or whatever it might be. Also, note the use of dashes in this ID in order to register with a custom element correctly. You can't use uppercase or camel casing or underscores in this situation. Must be dashes, just one caveat there. Next up is the name property. This is the human-readable name that will appear along the top of the node user interface that you can see in the screenshot there. So keep it short and understandable so it fits in the title bar. You can use a regular string with spaces as you wish here. After this, you've got the description, and in a similar form, this is a longer form string that appears when you hover over the eye icon in the node to inform the user what it actually does. In the next section, you've got a property called category. For now, category needs to be chosen from a predefined list, and it must be one of an input, an output, a model, a tensor, a search node, processor, or advanced type. By choosing one of these categories, this basically defines what panel your node will actually appear in when it gets rendered to the VisualBlocks interface, as shown on the screenshot. Also, related to this, you can specify a collection, which is highly recommended so people can find your related nodes grouped together in one place. So maybe you want to choose your company name or a common theme for a problem that it solves. In the image shown, you can see how this specific one I made appears under the JSON collection. OK, so moving down to the next section, you can define the property specs, which are technically optional. This defines an array in which you'll add objects containing the metadata for some property you want the user to configure at runtime when they're using the node. So let's walk through an example for a drop-down box so you can select the type of uppercasing we want to perform to this string in this hypothetical example. First, define the name of the property that you want the user to be able to configure. And again, it's important to use a name that's a valid JavaScript object so that you can actually access it in code at runtime in a suitable manner. Here, we're going to call the property option, which you can also see is exposed in the user interface as well. So that gets translated to the user interface so people can view it there as well. Now we can define the type of this property. And for this example, it's just going to be string as the type, as we're going to take in text as the input. Other possible types also include images, numbers, booleans, colors, string arrays, tensors, and many, many more that are defined on the slide there and are available on our GitHub code to view as well. Next up is the editor spec property. This is an object that defines the type of graphical component that's going to represent this property. In this case, we want to use a dropdown, but you can use other things as well. So we go ahead and define this and set type to dropdown so we get that effect rendered to the screen, and we can now see that's reflected in the user interface. So moving on down here, you can now define the options that will appear in that dropdown, and these are just an object containing value label pairs, and each one of these essentially contains a value, which is the value that's going to be passed in code at runtime, and then you've got the label, which appears in the user interface, the more user-friendly version of that. And you just specify that for all the options that you want there. Now, it should be noted that you could add more objects to the property specs array if you've got a more complex node, and that's entirely fine. You can just repeat this process many times with other types of things, and we actually support many other stuff out of the box, such as numbers, toggles, color pickers, text inputs, images, and more. So there's no need for you to go and program that yourself. We can do all of that for you. Now, let's move on down and define the inputs to the custom node. It should be noted that inputs are technically optional because not all nodes will require an input to work. So in that case, you could just omit this code if you wanted to. But in this case, we do need an input. So we're going to define an input spec property, which is an array of objects that define the types that the node expects to receive. In each input object, it's going to contain a name and a type. So let's walk through those very quickly. First up is the name property that the user will see in the node's user interface, as shown. And just like before, it has to be a valid variable name in JavaScript, so you can access it in the code later. In this case, you just call it text. Now, remember to keep your names descriptive, and try to use existing conventions from other nodes, so it makes sense to users when they're using Visual Blocks later on. For example, if you know that your node's going to work with another node that has text as an output, then you want to call your input text as well, so you've got a text-to-next connection going on in the user interface later on. Next, you can define the type. The type value in this case is represented as a piece of text with a value of string. However, it should be noted the value could be anything you want, allowing you to define custom types. So if you had a custom object that you wanted to pass as an input, something that's unique to your company, let's say an animal object, whatever that might be, then the string here could be animal instead, okay? And in that case, you must understand how to process animal objects. And a key note here is that Visual Blocks will not check for the type at runtime to enforce that. It's up to you to make sure you know how to handle that, okay? So if someone else comes up with another Visual Blocks node that outputs an animal, we will suggest that it's compatible with yours as an input. So it's important to use a unique name here that is unlikely to conflict with other people's object types. Moving on down, we reach the outputs of a node. And again, outputs are also optional. So here you can define the output spec property in a similar fashion as you did for the inputs. And again, it's just an array of objects containing name type pairs. And yeah, remember to make your name meaningful and short so it works really nicely as an end result for the user. So here we're going to name our output result. And we're going to define it as a string, because we're going to output a string at the end of this process. Now, at this point, I just want to call out that custom inputs and outputs, by convention, should be serializable. Even though we don't enforce this right now, we might assume this later on. So just bear that in mind. And if you wanted to pass something more advanced, like a canvas object or a tensor or something like this, we've got a special services property you can use, which is beyond this talk, but just know it exists, and you could use that to pass around things at runtime for more advanced things if you wanted. But this is not needed for our simple node. OK, so now that the node spec is defined, you can move on to writing the custom element, which is the logic of your node, essentially. This goes directly underneath the node spec you just wrote on the previous slide. So let's walk through that. So first, you're going to define a new class with a name that relates to your node's actual name. So here we're calling it make uppercase. And this is going to extend a HTML element, because you're going to create a brand new HTML element that Visual Blocks will then use in its interface. Next, define the constructor. And right now, we're just going to call super to make sure that everything is set up correctly for the HTML element class that you're extending. Nothing too fancy there. And then you're going to define a special function called run with inputs. Now, this is what Visual Blocks is going to expect to call at runtime, so you must expose this function on your custom class there. This is where you'll write all your custom logic in that function, essentially. And of course, you could add other functions as you need to help write that logic, but the run with inputs function is the only function we will call when we're actually using your node. OK, so at runtime, Visual Blocks will pass your run with inputs function an inputs object that contains the input data passed to the node from the user or the configurable properties that they've selected. In order to use that, you need to destructure that object to get the values out of that object so you can actually process them and do something with that. Now, if you're not familiar with JavaScript destructuring, this is an example of that. Essentially, because we've got text and option variables that we defined in the node spec earlier, we can just use those names in this object in order to take that from the inputs object and assign it to these variables called text and option, respectively. So it's a little shorthand trick you can do in JavaScript to do that. And then, now you've got access to the text from some connected node and the option currently selected from the dropdown in this node, you can write some custom logic to actually uppercase either the first letter or the whole input string as you desire, depending on what the dropdown value was. Now remember, at this part of the code, you could write anything you like. So maybe you're calling some cloud API, like the new Google Gemini API, or whatever you want, your own service. It could do anything you want. In this example, we're just going to uppercase the text, but you could do whatever you like here. Now, once you've got the result to pass on, it's time to dispatch an event with an output that you want your node to send on to any child node that's listening to your node as an output. To do that, you can call this.dispatchEvent, to which you pass a new custom event of type outputs, whose value is an object that contains a property named detail, which is a bit long, which contains an object named result. But the key thing to note here is that result was the name of your output that you defined in the node spec at the beginning of this talk. And that's why we define it as such here. And this value of the result object will just be the uppercase text that we defined on the previous line of code. Okay? So now we've outputted the thing we've actually transformed. OK, so now that the make uppercase class is complete, the only thing left to do is to register that class you've just created with Visual Blocks itself. And to do that, you can just call visualblocks.registerCustomNode and pass it an object with two properties. The first is the node spec that you defined at the very start of the talk, and the second is the node implementation, which is the class that you just created. OK, so now you've coded your first custom node. How do you actually go about using it? Well, you need to ensure that the JavaScript file that you just created is hosted on a web server with the correct CORS header set, which stands for Cross-Origin Resource Sharing Header. So basically, that allows the Visual Blocks domain to take that JavaScript in and actually execute it without any security issues, essentially. So if you're not using Google Cloud Storage, for which I've got an example here, you'll need to look into your web server's documentation to set that up correctly. But you do that once, and then all your future files should work very nicely. So assuming you've got your JavaScript code hosted, it's time to actually use it. Now, I've hosted this code on a nice CORS compliant server for you already up on the Google Cloud Storage. So if you want to try this out along with me now, you can just go to that URL and copy the resulting URL that transforms to. And once you've got that, you can open up the Visual Blocks editor, as you saw Nar using earlier. And you can do that by going to goo.gle/Visual Blocks editor. And uppercasing is important here, so make sure your uppercasing is correct. Feel free to take photos. I'll give you a few seconds there. Very good. And then we shall be able to use it in Visual Blocks. So once loaded, you can click on the tiny black circular icon that appears at the bottom left of the Visual Blocks editor. And you can paste in the URL that you just got from my cloud storage bucket and click on the OK button. Once that's applied, you see a little green checkbox to say it's been imported correctly. And with that, you can now start to use the custom node. Now, remember, in this tutorial, I put my node under the JSON collection. Okay? So you'll see a little drop-down appear but you can choose different types of collections. Go to the JSON collection in this case, and then you can drag out the node like you would any other Visual Blocks node. And with that, you can see how I can then use it with all the existing nodes that Visual Blocks already has. If other nodes produce text as an output, I can use it as an input to my node. And if I'm outputting text, other nodes that take text can actually have them as their inputs. So in the top green flow here, you can see I'm just uppercasing the first letter of a sentence. And in the blue flow, I've changed the dropdown to actually uppercase all the letters. So you can see how I can use it multiple times in multiple different ways and start chaining it together to do very powerful things. Now, of course, this is a simple example, but imagine if that was a large language model or doing something more interesting. You could do some amazing things by combining nodes together. OK, so now we've got a working node. Some of the keen-eyed among you might have noticed that other nodes in Visual Blocks have their own user interfaces, such as this text box, where you can actually just type in at the top there without having to connect any inputs at all. So how did we pull that off? Let's see how to do that. Again, if you want to follow along for this part of the code, you can take a photo of this URL to look at later. This will contain the completed code for this section of the demonstration. I'll give you a few seconds to whip out your cameras. Thank you. Very good. Lots of cameras going up. And then, awesome. I'm going to continue. So first, we head back to the constructor that we defined before. And here, we're just going to add 3 lines of code. Here you define a variable named textArea to hold a reference to the HTML textArea element that you're going to add shortly in the next section. For now, just leave it as undefined. And then you're going to attach a shadow DOM to this custom element. This allows us to create an arbitrary piece of HTML inside this element that's encapsulated. Now, essentially, the HTML that you'll specify later is the custom element itself, as opposed to all the other HTML on the web page that's other things. So this HTML will become our custom element, and that's how it gets rendered later on, OK? So you need to set this special thing called mode to open so that you can grab references to those child objects later on in the HTML to manipulate them and use them as you need. If you set it to close, then you won't be able to access that HTML that you add. So just bear that in mind for later. Finally, you can call the render function that we're going to define on the next slide to actually render all this and get some nice user output for our node. OK, so here's the render function. And that's placed right underneath the constructor. And this is where you can add the HTML and CSS that you want your node to use to expose that nice user interface. So with that in mind, it's time to actually inject some HTML that you want to use into your custom element shadow DOM. In this case, you're just going to manually set the CSS style properties in the HTML element itself for ease of following along. However, it's recommended to split this out into its own file for good practices and that kind of thing. Now you can see that here, the CSS just makes the text area fill the width and height of the node itself, and it removes any default border that the browser might apply just to make it look pretty, and that's all it does. Next, you'll define a HTML text area element with the ID of text area, and that's what we actually will use as a user to actually input text into the node in this use case. OK, so now that the shadow DOM's been rendered to the screen in the previous section there, you can grab a reference to the text area you've just injected, just like you would do any other HTML element on a web page. The only difference is that you must use this.shadowRoot in order to get at that, instead of the regular document.getElementById. But otherwise, you can use all the regular JavaScript functions you would use in JavaScript to get at the DOM. OK, so the next step is to add an event listener on the text area that you just added for the blur event. This will detect when the text area has lost focus, so you can click out of it and then apply some transformation to it. And that's when your custom logic will then be triggered, essentially, when you click out of the text area in this case. So to do that, you can add a pipeline rerun trigger event on this instance of the custom element to tell Visual Blocks to recall your run with inputs function with the new data that's been entered from the text box in this situation. And finally, don't forget to bind the function that's being called on the blur event so it uses the correct context for the this keyword in the JavaScript. So you want to actually make sure it's called on the custom node and not the text box itself. OK, so you're almost there. The last edit you need to make is to update your run with inputs function to check if a node was connected as an input with some text to be used. And if not, you're going to overwrite the empty text with the value from your text area that the user might be using in the user interface. And that's all this code does. And all the rest of the code is exactly the same as before. OK, so time to try it out. This is the completed code for that exercise. Again, take a photo and try it in your own time later. That's completely fine. And I'll give you a few seconds to do that. Okay, cool, excellent. I see some phones still up, 2 seconds more. All right. So, just like before, you can add a new custom node and then check for the new version of a node, but that will appear under the same collection as before, the JSON collection. And you can then use this new version of a node whereby you can actually type in the visual editor of the node that now appears in the, along the top of the Visual Blocks editor. So with that, today you've seen the power of Visual Blocks along with how to make your very own nodes to work with any ecosystem, including anything you might have at your company. Now, while some custom nodes you want to keep private, that's completely fine. We also hope that the wider community will contribute reusable ones for all of you to also use as well. Maybe you've got some third-party API you want to see in Visual Blocks or some custom logic you want to write that everyone else can reuse. So we look forward to seeing the community grow in that regard. And on that note, we'd love to see what you make. If you make a custom node and want a chance to be featured at our future events, please use the hashtag VisualBlocks on social so we can find your lovely work and help promote it and get more eyes on it. And after that, of course, please give us your feedback for today on your apps. And with that, thank you very much. If you've got any further questions, I think we've got a bit of time, 10 minutes or so to take them now. Otherwise, we can meet outside. And otherwise, you can ask Nar and myself any questions on LinkedIn and Twitter after the show. So thank you very much for listening. And yeah, if you've got any questions, feel free to ask. Cheers. Is there a mic going around, or I'm not sure? Oh, there's a mic. OK, so anyone with a question, just raise your hand, and there's a microphone coming around to you. So yeah, I think there's a guy in the middle somewhere here I saw put the hand up. Cool.
Someone has a question.
Oh, here we go, this guy. OK, perfect, yeah.
So just a question about the final result. You know, if you go back to the original example that you showed with yourself, you know, with adding the glasses and all, right? Mm-hmm. How can I take that from that interface that you showed and include it in my website?
Great question. So for now, VisualBlocks is a prototyping tool as a standalone website. You can go there and try, and you can click the export button to save it and share with friends. And this year, we do have a plan to have a deployment story for it, meaning that you can use just the upper part, which is the runner, and embed into your application surface. So stay in tune.
Coming soon. Yes, question over there.
Sorry, I'm new to VisualBlocks, but does it have integration with any kind of like version control or anything? So that way if you're making changes and oops, you want to go back to what you were doing earlier, is there any kind of revert or anything?
In terms of the graphical flow, in terms of the custom node that you're making or something like that?
In the graphical flow.
Oh.
The whole graph is serialized into a JSON, and you can attach any metadata. For example, you can attach a version to it and use your application to check the version.
So you could commit that to GitHub or something if you wanted to, and then version it like that. Yeah, that could work. Is there another question? Over here. Oh, here, yes, okay.
Hello. Question is about complex data. Can you have input with that tabular data? It has many records, and you want to process with different blocks. That'd be one question. And the second question would be about the partial output passed down to another components or combination of the different components. But let's say you can, written complex nested object, the first block, and then you want to specify, let's say, XPath kind of style, that you want to only extract certain piece to be input for the next component.
So the first question was tabular data. So we've actually had integrations with Google Sheets in the past, I believe, right? So like, as long as you know how to process that input, you could pass anything there, but as long as you know how to process it. So if it's a Google Sheets URL, you need to know how to then access it, grab the data, and do whatever manipulation you need to do in that situation. Or if it's like a CSV file or something like this, you need to know how to process that. So you could have a property in that node to say, like, okay, this is going to be a CSV file or a Google Sheets link, whatever it might be. So you could write that. That is technically possible. And we've got examples of that internally that are not yet public, but yeah, we've made those kinds of things in the past. And then the second question, again, was
nested.
More complex objects passed.
Is it nested a JSON object? Yeah, so complex objects, there are two types. One is that can be serialized, for example, a deeply nested JSON object. That can be passed with no problem. And actually, there's a node called text processing. And if you choose the mustache option from the drop-down, it actually can visualize the deeply nested JSON object and allow you to pick any field from there. And then for complex objects like what Jason mentioned, Canvas and Tensor, you can also pass along those complex objects as is. And if those data stay in GPU, they will keep staying in GPU. That's how we make that real-time image pipeline.
Yeah, so for those ones, you'd use the services object that I spoke about. There's a link on the slide that if you go back in the talk, you'll see the link to see an example of that in action. And that keeps it all memory efficient and stuff like that. So, yeah. One question over there, I believe. Yes, and then over there. Cool, yeah. Oh.
Hello, a quick question for you. I'm coming from the K-12 education space. Currently, I'm teaching my students about how to various languages. Using the visual aspect of it might be a lot more helpful to our younger students. Is there a Khan Academy style like course or things like this teaching people how to use this that I could use with my students?
Oh. I guess that's a to-do for me at some point. I do have a basic video showing you how to make that AR effect you saw earlier and a few other things just to kind of show you how to use Visual Blocks, but I don't have a dedicated course right now for exploring all the magical things you could do in a nice style like that. I'll add that to my to-do list. And of course, if anyone else wants to help create content like that, I think that'd be great to see the community also contribute to as you make more nodes and have more examples that we can show, especially for educational purposes as well. That'd be very interesting to do, actually. So maybe connect with me on LinkedIn afterwards. We can have a chat. Yeah. Over here. Yeah.
Hi. My question is, where does Visual Blocks fits in Google offering of AI and ML products? Who is the target audience? Is it developer or enterprise customer? Because even to do any POC, we need data, and taking data out of enterprise databases is quite difficult.
Yeah. So, I mean, from my perspective at least, I guess you can think of this as a framework that's agnostic to any end use case. So for lack of a better pun, we provide you the building blocks to work with anything you like. If you need to access a database, then that would not be in scope for us to do that. But whoever makes that node for your company would need to get the permission to access that data to use in a flow like this. But because this is all running in JS, you could run that node from localhost like I did in one of my examples, and then that's all running locally on your infrastructure, and it can be private if you needed it to be. So there are options to maybe alleviate some of those conditions that might be concerns for those people. Yeah. Oh, can you put the mic there? I can't hear anything. Thank you.
Can I think of this as a LangChain type framework?
Actually, I was speaking to LangChain. I got a good friend there. They almost feel like this is like a visual version of some of the things they're doing. So I think they're exploring, looking to see if they can use this kind of stuff in the future. But for them to decide, of course. But yes, interesting times.
Thank you for your talk. Could you speak a little bit more about model integration options? Like, does the built-in integration wrap around TFGS or Onyx models, or what? Yeah, can you speak a little bit more about that?
Yeah. So we have TFJS runner and TF-Lite runner, and you can just provide a model URL and drop in those two runners, and you can run any TFJS or TF-Lite models in local. We also have a node called custom API. There you can provide endpoint and the JSON payload, and it supports GET and POST. That allows you to call into any remote endpoint, like model serving on the cloud. And also you can use this custom node function to implement, to integrate your model, whether it's from the cloud or it's local, it's all up to you.
So yeah, TLDR, you can integrate everything. If it doesn't exist, you can write a node for it, and then you could run Onyx Web or something else if you wanted to, or just call an API if it's on the server. So yeah. Yes, in the middle.
All All right, awesome presentation. Okay, so I think you might have answered my question. So you're saying with this, it is an opportunity to actually put an endpoint. If I build something, I'm building a prototype, can I put an endpoint on it and hit that endpoint from my custom application?
Yes, so if you've got some service in the cloud that does X, you can make a custom node for X that will call your endpoint and be able to use that within the Visual Blocks user interface, essentially. So, so maybe you've got like a large language model in the cloud. You could then use our text node to do some text manipulation, feed that as an input to your node, which sends that request to your cloud server, gets a text response, which you then feed onto another node to do something else. And yeah, you could do that kind of stuff very easily. Yeah.
And then you can attach an API key to it so that if you want to protect your endpoint, and you can make it only accessible to people who have an API key.
Yes, that's a great use case for the custom user interface I just showed, actually, where you could have like a little input box for API key that you use at runtime but isn't saved in the metadata of the project itself, for example. So yeah, cool. Yes, down the front.
Thanks so much for the talk. So I was really interested to find out what was been most surprising from when you've seen users start to interact and prototype in a visual way.
Which ones can we talk about publicly? You've got some good experiences, I think, with some of the team. Right?
Yeah, you can talk about.
Oh, okay. Okay. Well, I mean, we've seen a lot of Google teams use this internally to prototype faster, and there's actually a whole Kai paper. If you search, it used to be called, what was the original name of this project?
InstructPipe.
Oh yeah, search InstructPipe on Google, and you'll see how we've managed to integrate Visual Blocks with a large language model to say, hey, we've got all these nodes that do this as an input and this as an output. Rearrange these nodes so that you can produce an AR effect. And it actually builds a pipeline for you, which is incredible. So we're starting to investigate those kinds of areas too, which is very interesting. And this is just scratching the surface of what we can do today, but going forward to tomorrow, there's some very interesting possibilities. And then for internal teams, we've seen a number of teams that I can't mention the names of, but across the board, they've been prototyping with Visual Blocks and achieved fast prototyping times and iteration times that we couldn't get before. So, yeah. And some of those details are in our paper that talks about all that. Yeah.
And basically, any large language model that's multi-model, that's interesting. Because we've seen more pure language pipelines, and we've seen like traditional image pipelines. And now large language model has expanded to take image and text. And also it can generate image and text. And we've seen, like internally, they're developing many models and use this to try all different possibilities.
Yeah. This is really good for like model comparison as well, because you could have two parallel pipelines going on at the same time, where you've got maybe like two segmentation models, and you're like, which one's better to deploy to production? You could have live camera inputs coming into both at the same time and comparing the results for the same frame of image, and actually say, oh, but it's missing the hair on that person over there, I didn't segment it properly, and you can then decide which model to push to production and all that kind of stuff. So, yeah. Oh, question over here.
Thank you for the presentation. My question is, can the nodes that we define, when they get data from somewhere, let's say, can we store them somewhere within like another node or something? Because often we have ideas about doing something, but we need to kind of store the data. But I don't want to like have a database and all that kind of stuff. So how is that handled?
Okay, interesting.
That's a good idea. Yeah. I think he's mainly talking about subgraph. There's a part of it that's reusable, and you want to save it, and you want to use it in different pipelines. Is that?
Yes.
So what was the last word?
But I'd like for it to have some kind of memory.
Oh, okay. So everything you do in Visual Blocks is saved to a local storage. So if you refresh the page, it's all there still. If you save the unique URL it gets. And that's stored in your local storage on your computer in the browser. So you can also export to save a JSON file that Nas spoke about before if you want to permanently store it on GitHub somewhere for others to then use. But any graph you create can be is by default stored in local storage. That is the database we use to persist over a session or when you close the browser and open it again, that kind of stuff. So, yeah. Yeah.
For instance, you get a data response back. So you're saying that I could store it in my local computer, and the next time I run it, I can...
Oh, for the response, I've got you. So I think that would need a custom node. Maybe you need like a persistence node that basically collects strings or whatever, and then you could dump data into that, but then take its output to then put that into other nodes later on.
Got it. No, I
Treat it like a buffer or something. You could do that, but would need to be custom. We don't have one of those yet.
And can the custom node be developed in Python or something like that, or do we have to use JavaScript?
JavaScript.
Right now, everything is JavaScript here, but we do have a Colab integration that allows you to expose Python code as a block within Colab. But that's not the same as the interface we showed today, which is all just running in the web browser. So yeah, cool. The guy over here, you had a question? Yes, sorry, lady with the microphone. Oh, yeah, this guy.
Yeah, I had another question. Assuming that you could use those block visualization as a workflow, right? In order to reuse a lot of things, would it be a mechanism needed to, for example, encapsulate, let's say, any user-defined nodes as a block on its own that can be reused later by someone else? Is that kind of functionality exist today, or does it need to require like custom node build-up that encapsulate the other nodes?
So are you saying if a custom node includes another custom node itself?
So imagine I have like, I don't know, some transformation of the image, right? Like
yes.
A few steps, okay. And now I want to hide all those implementation. I want to call it image transformation block.
Okay.
I
Right.
don't want coded as a custom element. I want to just have kind of encapsulation for those blocks that's already in this one particular.
So just the code part without all the extra bits.
Because there could be thousands of the scenarios that you want to reuse some
outside of the visual blocks
combination
editor.
of the
yes, got it. So that's something that Noah was touching on just as, towards the end of the presentation when she was talking, is that our plan is to allow people to export essentially the core logic of the nodes to a bundle, which you can then take and use somewhere else. We haven't made that yet, but it's in our ideas for the rest of the year to actually do that. So in my mind, the 3 key pillars of Visual Blocks is first, making it exist, which was last year. The second thing is to have the custom nodes to allow people to make custom integrations. And then the third pillar is the ability to then export those made pipelines as a standalone bundle to then integrate in a production application. And that's something we're looking into as a team. So yeah. I think there's maybe one other question if we've got time or not. Maybe who had their hand up? No? Okay, we're good. Well, in that case, find us on LinkedIn if you've got questions, and thank you very much once more. Thank you.